Welcome to your video lesson for Thursday, April 4th. We are continuing to work on our fourth unit, Trig Functions. Today is mostly, hopefully, going to be a review of grade 11 Trig, where we talked about special angles. Our learning goals, we're going to use special angles in the Cartesian plane to evaluate some trig ratios. We're also going to get used to using our calculator in radian mode. First thing, this diagram basically helps you kind of decide where angles should go when it comes to radians. So there's degrees on the outside, there's radians on the inside. Again, that just is a helpful diagram for you to get practice in terms of which radian measure, which just boils down to fractions, what fraction is where in the circle. And along with that, just going to say there's two ways to typically solve any trig ratio when they're in radians. You can convert to degrees, or, so we converted to degrees on Wednesday, or you can work with your calculator in radian mode. I'm going to encourage everyone today to work with your calculator in radian mode, but for a test, if I don't specify, then you really could do one of either of those two ways. To give you some time to copy down that circle, you could just hit pause, and then once you are done copying it down, you can move on to the next slide. So we're going to start out easy. Solve each in radian mode. First thing you need to make sure your calculator is in radians. So either hit the DRG button so you see the R for radians, or change your mode, keep hitting mode until you see radians and change it to radians. For the first one, you're literally just typing that into your calculator. Make sure, though, that you enter it as pi over 2 in brackets. So you literally just type in sine, open bracket, and then use your pi button, divide it by 2, close bracket, hit equals, and everyone should get 1. If you just type in sine pi divided by 2, that's going to give you a different answer because your calculator is going to do sine of pi first and then divide it by 2, whereas we want your calculator to tell us what the sine of pi over 2 is. Next one, literally type in tan 5. We'll round to 2 decimal places. Hopefully you got negative 3.38. Next one, just like A, make sure you enter 3 pi over 4 in brackets, so cos open bracket 3, use the pi button, divided by 4, close bracket, and you should get negative 0.707. Cosecant. We don't have a cosecant button, so you got to remember that cosecant is one of your reciprocal trig functions, which cosecant goes with sine. So this is equal to 1 over sine 2.25. Type that into your calculator, 1 divided by sine 2.25, hit equals, and you should get 1.29 if we round. Easy stuff so far. This next slide, just pure recall. So I have two different ways. This is talking about special angles. So you could think of the triangles themselves. So you have to have those two things memorized. Or if you want to think of it in a chart, you can think of all those special angles memorized in a chart. It's completely up to you. Secondary trig ratios, we're going to recall. We just did one. And the cast rule. So secondary trig ratios, we just did cosecant theta equals 1 over sine theta. Secant theta equals 1 over cos theta. And cotangent theta equals 1 over tan theta. Our cast rule from grade 11, Cartesian plane. We have, start down here, C-A-S-T, which means only cos is positive, all are positive, only sine is positive, and only tan is positive. Along with that, we have a couple other things. We have what's called the bow tie rule. So whenever you make a triangle in the Cartesian plane, it has to make a bow tie. So your triangles.
Room 251.
Your triangles always have to have the x-axis as the base length. And these, of course, make 90. How you think of sine, cos, and tan, again, you can think of it in terms of SOHCAHTOA. So sine's opposite over hypotenuse, cos adjacent over hypotenuse, and so on. Or, depending on your teacher, maybe they said circumference, which just means sine is y over the radius, c is x over the radius, and t is y over x, which tan. Just like the last one before, if you need time to copy all that down, it would be a good time to hit pause and then move on when you're ready. We want to find the exact value, so we don't want the approximate value. We want the exact value of each one of these. First thing, draw your Cartesian plane. 5 pi over 6. Now you either have to have this memorized or you have this diagram in front of you. 5 pi over 6 is right there. So we know that our principal angle is in this. And we have to remember that our principal angle, so this is from grade 11, will equal the correlated acute angle, which in other words means if this is theta, so that's actually 5 pi over 6 radians, that will equal this angle right here, which is beta. So theta will equal beta. The correlated angle is always going to equal the principal angle. So in order to do this, 5 pi over 6, we know that the x-axis makes pi, so really what that leaves us with is this is pi over 6. That goes along with one of our special triangles. And if you look back at your special angles, you are going to realize that that goes with your pi over 6 triangle. So that has a hypotenuse, or like the radius, the r value of 2. And then across from pi over 6 is 1. And adjacent to the pi over 6 is root 3. We want cos, so you can think of cos as adjacent over hypotenuse, or if you prescribe to the circumference acronym, then we know that, so the kicks, the y over our hypotenuse. So cos is adjacent over hypotenuse, or x over r. So this cos 5 pi over 6 equals root 3 over 2. And last but not least, you need to use your cast rule. So cos bottom right, all sine top left. So that would be negative root 3 over 2. Our next one, 11 pi over 4. So you're going to notice if you look at that circle, there is no 11 pi over 4 on there. So 4 pi over 4 would be 1 pi. 8 pi over 4 would be 2 pi. So basically this goes around the circle more than once. So we know that the 2 pi spot would be 8 pi. And what would be left over would be 3 pi over 4. 3 pi over 4 would be there. And if that's 3 pi over 4, and we know that the x-axis is pi, that's just going to leave you with pi over 4, which leads to our special triangle, 1, 1, root 2. This is asking for tan. So tan 11 pi over 4 equals opposite over adjacent, or y over x, which is 1. And then based off of your cast rule, only sign is positive in that quadrant, so that makes it -1. C, -240. -240 just means you're going around clockwise. So we're going to go, there's 180, and that's going to put us there. So if I went around just to the x-axis, that's 180 degrees. What's left over from 240 is 60. So we know that that is 60 degrees. We can keep it in degrees since it was given to us in degrees. We know that's 30. And if you use your special triangles, this goes to our 60-30 triangle. We know that our hypotenuse is 2. Across from the 30 is 1. Across from the 60 is root 3. We want tan, opposite over adjacent, y over x. So tan -240 equals opposite over adjacent, y over x, root 3 over 1, which is just root 3. Based off of the cast rule, only sign is positive, so that would be -root 3. And D, secant 150, so 150 degrees, puts us here. That leaves me with 30 degrees. Remember the x-axis is 180, so that's 30 and 60. Exact same special triangle. 2, across from the 60 is the root 3. Across from the 30 is 1. Now this is secant, so you got to realize that basically secant's just cos flipped. So if we do the cos of 150 and then flip our final answer, we'll get secant 150. So cos 150, cos is adjacent over hypotenuse, or x over r, root 3 over 2. Only sign's positive, so that's negative. So that means secant 150 is the reciprocal of that, the flip. So -2 over root 3. And since we don't want radicals in the denominator, that would be -2 root 3 over 3. Example 2, last one. So this one kicks up a notch of difficulty. We got sine squared pi over 4, then we got 2 times sine 13 pi over 6, and then cotangent pi over 3. So let's make a couple of these diagrams. First of all, pi over 4. That's in that quadrant. Pi over 4, 1, 1, root 2. So we're going to figure these things out kind of one at a time. So we know that sine pi over 4, everything is positive. They're all positive in that quadrant. Sine pi over 4, opposite over hypotenuse, y over r, 1 over root 2. And positive. Let's do the 13 pi over 6. So 6 pi over 6, that'd be go half circle. 12 pi over 6, full circle. So this is 1/6 bigger than 12 pi over 6. So that puts us in this quadrant. And we're left with pi over 6. That would be pi over 3. Our special triangle, that's 2. Across from the pi over 3 is the root 3. And 1. And they're all positive. So sine 13 pi over 6 equals opposite over hypotenuse, or y over r, 1/2. And again, they're all positive. And then cotangent pi over 3. Pi over 3, first quadrant. That makes that pi over 6. That's that special triangle again. So 2, and then across from the pi over 6 is 1, and across from that one, root 3. Cotangent. We don't have one for cotangent, but we know that we have one for tan, which the reciprocal of tan is cotangent. So tan pi over 3, and again, they're all positive. Opposite over adjacent, y over x, root 3 over 1. And if we flip that, we'll get cotangent. So 1 over root 3. Now we can put those all together. So to solve an exact value, sine pi over 4, we got it right here. That is 1 over root 2. And it's sine squared, so we want to square that, plus 2 times sine 13 pi over 6 is 1/2. So 2 times 1/2. And we're going to multiply that by cotangent pi over 3, which is 1 over root 3. 1 over root 2 squared is just 1/2. 2 times 1/2 is 1, times 1 over root 3 is just 1 over root 3. You can leave it like that if you want to show off. You could, depending, sometimes the textbook will take that further, so you'll want a common denominator, which is 2 root 3, which would make that root 3, and then plus 2, all over 2 root 3. And then things would get even dicier if we want to get rid of the radical in the denominator. So multiply everything by root 3. So that's going to give us 3 plus 2 root 3 all over 2 times 3, which is 6. More than likely, that's how the textbook's going to leave it for you. Our last question. Find all possible values of a between 0 and 360 for sine a equals 1/2. So this is kind of going the opposite direction than what we've been doing. First of all, that ratio is positive. So we know that sine is positive here and positive here based off of the cast rule. So we know that we have 2 possible triangles or 2 possible angles that leads us to our solution. 1/2, that goes with one of our special triangles. So sine is opposite over hypotenuse. So hypotenuse would be 2, or the r, the radius of our circle. And our opposite, now remember these are always our angles. Our opposite would be 1. So 1, 1, 1, root 3, root 3. Now looking at those, you have to be able to pick off what theta is in this case, or what the correlated acute angle is. So the one that's always across from the 1 is the pi over 6. So we know that that right there is pi over 6. So that means A equals, so A equals that angle. That would be like solution number 1. So A equals pi over 6. And going all the way around to the other one, so going all the way around to here, would be solution number 2. And you kind of got to know, so since everything's in 6, remember that's basically 6 pi over 6, because that x-axis represents pi. So basically we want to go pi over 6, kind of going back this way, which amounts to 1/6 less than 6 pi over 6, which is 5 pi over 6. So A equals pi over 6, and A also equals 5 pi over 6. And just know, we're doing the exact values for all of these things. You can always use your calculator and double check all of our solutions throughout the entire lesson today. You can go through and type them in just like they see it. Type in sine pi over 6, you should get 0.5. Type in sine 5 pi over 6, you should get 0.5. Granted, your calculator's in degree mode. And you can do that for any example that we did today. or for the homework to check over your work. That's it for your video lesson. Tomorrow I'm away, so Thursday I'm away. Friday we're going to do some graphing, sine, cos, and tan. Some more graphing on Monday. And then Tuesday and Wednesday, trig equations. Your test is on the 17th, rewrite day on the 18th. There's your work. If you want to get a head start on it tonight, you can. Otherwise, I would just focus on Wednesday stuff for Wednesday night and then save this work for Thursday in class. Have a great night. Have a good day tomorrow on Thursday, and I will see you all on Friday.